Welcome! Now it works. My name is Seba. I'm a UX designer at Google, and I'm here today together with Steven, Alfonso, and John to talk about online identity experiences and how to make them better. But first, I'm going to need a volunteer from the audience, and you taking a picture. What's your name? Libby. Hi, Libby. Nice to meet you. I'm Seba, that one there. So that is a pretty normal, everyday identity experience. Just ask somebody their name. Now we know each other. Now I can refer to her. Now I can even make this presentation better. Can I use your name to make this presentation? Excellent. Thank you. So let's see if I want to do the same thing online. Let's say I have an app about food, and Libby is trying to use it. And she will have to decide if she already has an account or not. She kind of heard about the app before, but she's not sure. So she's tried to sign up for the app. So she'll have to enter the email and the passwords. The ducks are the password counters, by the way. So I have to type 2 times her password. And the account already exists. She forgot that she already signed up some time ago. So she tries to sign in. She types her password that she uses every day. Libby, please don't use the same password always. It's not safe, by the way. But anyways, she tries, and it's not the same password that she used last time. So since Libby is my best client ever, and she's going to keep pushing to use this app, she's going through the recovery flow. So she'll have to type her username, check her email, go click here, and then she'll be back to reset her password. She's going to type 2 times again her password, and success. The password is reset. She tries to sign in. Thank you, Libby, by the way, you're best. So she signs in, types another password, and finally, Libby, it's in. She can use my app. But you never noticed that you're signing into the website, not to the app, because the recovery flow is a web flow. So you have to switch, and finally, another password, and you're in. Thank you, Libby. You're the best. Please, for Libby. So as you can see, it's not very easy for Libby to remember passwords and so on. Even to remember that she had an account, or how they sign in. You can use passwords, you can use a phone number, you can use IDPs. And it's quite frankly, very difficult. And also in my, kind of shame to say this, 17 years of experience designing websites and apps, I never had a client asking me or telling me this. Our magical experience is going to start by asking everybody to sign up or type a password. That doesn't happen. Usually it goes like, we have this app and this technology, it's going to do this, and it's going to be awesome, and it's going to be great, and Libby's going to love it. And so like, okay, all right, so you have to sign in users. Oh, yeah, and you have to sign up to create accounts. Oh, yeah, well, after that, it's going to be awesome, it's going to be great, and we're going to do this and that, and blah, blah, blah. And to be honest, that happens a lot, and it is how it should be. You should not care about your authentication system because it's not your business, it's not your core functionality. But the downside is that without that, nothing works. And here said no one ever said that. So it's also very difficult for developers to do it because you have to cover all these cases. You have to keep it secure all the time. And you have to cover all these platforms that Libby uses, like phone, watches, computers, blah, blah, blah. And it's very difficult to do. So we believe that it should be simpler, it should be easier. And today, we're going to talk about these 3 products that we're working on to make that thing happen. Here you go. John?
Thanks, Eba. I'm John. I'm the Eng lead on Identity Platform. And if you went to Sabine and the Chrome Web Security team's talk yesterday, one of the interesting details that you might have learned is that the top password in 2015, 1234556. And of course, this is followed very quickly by the number 3 password, which is 2 orders of magnitude more secure, 78. And if you take a look at the top 20 passwords, you'll see that 6 of the top 20 actually are simply just number sequences between 1 and 4 and 1 and 9. And most of the rest of them are just character sequences straight down the line as well. QWERTY, things like this. And of course, we have the illustrious number 2 of password. Now, there's 2 ways that we can look at this. And one is, as of course, a problem statement that we talk about a lot of the time. This is a huge problem when people secure their lives, their online communication, their payments information, their financial information, and so on online. And I think that's been pretty well documented. But the other way we can view this is as an opportunity, and that's what we see with Identity Platform as well. The opportunity is engendered in the fact that each one of these passwords, the salient feature of them is not that they're bad, it's that they're simple. Users demand that degree of simplicity, and it's our challenge as Identity Platform and as the developer community overall to present an equally simple user experience that increases the user's security. And that's the theme underlying our work with Google Sign-In in the last year. Now, Google Sign-In is a product that we're all familiar with. It helps users sign in using their Google accounts to your app or website. So what have we done to help simplify this for users as well as for developers in the last year? Now, I'm sure that everybody has seen a consent screen, which is the first thing you see when you tap Google Sign-In or any other identity provider that looks something like this. It's a wall of text. There's a bunch of stuff to read and understand, and you might ask yourself, what actually am I sharing with this site? Does the site even really need it? Are they going to spam me? What actually is here? It's not especially clear, and every moment that the user pauses to consider any of these questions is a moment they could just bail out of your app to begin with. Now, not everybody is quite as persistent as Libby. So what did we do to help counter this? We created the Account Chip UI. Based on the concept that what you see is what you give, Account Chip UI shows exactly the information that will be shared with the website. In this particular case, and in general, we focus around the concept that we call basic profile, which is what we've focused our SDKs around overall too. The core information that we found in surveys with developers that is necessary to get you into an app or a site. Photo URL, name, and email address. It's just that simple. Let's take a look at what it looks like with one of our partners, Doodle. Open the app, tap Connect with Google, tap the account information, and you're in. Doodle can sign you in or sign you up using that information pretty straightforwardly. I'm happy to announce that while we released Account Chip for Android during last Google I/O, within the next couple of weeks, we're going to be rolling out this functionality on web and iOS finally, such that you have the same experience no matter which platform you start on. But that's only half the experience, because we also wanted to work to simplify the integration process for developers as well and to make it faster and more robust. And we did so by focusing all of our SDKs around the concept of ID tokens. ID tokens are JWTs, JSON Web Tokens, which is encoded JSON, which includes a bunch of information, including the profile information that I just mentioned to you before. And that's partnered with a cryptographically generated signature signed with Google's private key, but which can be verified using Google's public key on your backends, using libraries that are both open source as well as provided as part of Firebase Authentication's server-side SDK. To illustrate how this helps simplify the sign-in process for your site, let's talk about the old flow. And this is the old flow, wherein you call the sign-in API, and in response, you'll get an access token or a code, either of which you'll end up having to send to your app backend. If it's a code, you add even more complexity exchanging it for an access token. But in either case, you have an app backend that then needs to make a get info call or a user info call to the identity provider's backend to actually get the user information that you translate into an account record. Now, this is important to note that this is a live call that happens while the user is signing in, so it adds latency. A bunch of things can go wrong. And it's actually not standardized either over identity providers. So you need to implement custom code to be able to pull this stuff apart, actually get the information you need, name, email address, and so on, and translate that into user record, which is represented as a cookie or session info. Now, as developers, we know that less is more, and any complexity is bad complexity due to Murphy's Law. Anything that can go wrong will go wrong. So ID tokens are great because they help remove this entire middle stretch where we have to make a request to the get info endpoint, figure out what the information is, and return it. So let's take a look at what the ID token flow looks like. Now, you call the sign-in SDK, and in response, you'll get an ID token. That ID token can be sent to your app backend and can be decoded by verifying its signature. Once the signature has been verified, the information within it can be trusted, and as I mentioned before, that information contains all the basic profile information we included before, which can be used to translate into an account record on your backend, as simple as that. So let's take a look at what this looks like on the client as well as the server side. On the client, you'll notice here on Android, as an example, that our default setting is now simply just to request basic profile information. You build the Google API client, you fire an intent, and upon the sign-in response, you'll end up being able to pull out the ID token, just as simple as that. Now, the Firebase Authentication Server-Side SDK has been launched with the rest of the Firebase Authentication product, which we announced 2 days ago. It exposes an API that you can see right here called Verify ID Token, which does all the heavy lifting for you of decoding the token, verifying its signature, and doing a bunch of additional security checks too. Once the token has been decoded, it contains all the information that you need. So JavaScript looks very much the same as well, wherein you call sign in, and in the response you have an ID token, which you can send to your backend. We support Node.js in the Firebase Authentication Server SDK too, which exposes the same method, verify ID token. In its response, you'll have access to all the information that you need. But that's only half the story. As much as we love Google Sign-In, and I do, we have to acknowledge that there's a number of password accounts out there as well. And to talk about how Identity Platform helps improve matters for that, I introduce Stephen Sonoff.
Thanks, John. So my name is Steven. I'm a product manager on the Google Identity Platform. And today we're going to talk about what happens next. So once you've taken John's advice and you've added a Google sign-in button to your app, you might have a sign-in screen that looks something like this. And let's see what happens to Livy when she comes across this experience. So now there's a few buttons at the top, and you have to remember which one it is that you picked last time, and have to sort out what will happen if you pick a different button next time. There's still problems of all those legacy existing users who have a username and password. And then there's this perennial problem about having different forms of sign-in, sign-up UI, and the confusion between them. And it gets even worse as we go to mobile, where you have to type all of this information in on a phone, and it can be really painful. So all of these pieces add up. In studies that we've done and industry research that we've looked at, we find that nearly half of people who see a sign-up or sign-in screen don't actually end up completing the action successfully. So this can range from all manner of things, from picking the wrong button and getting into a confusing situation, to remembering, having to remember your password and recover it, to being confused about trying to create an account when one already exists, probably an experience that you've seen yourself. And so if you put all these little pieces together, it can be a really major drop-off in the users that you see to your app, that if potentially half of the users who are trying to complete a transaction or sign up or subscribe to your app are dropping off in one of these flows, that's as many as twice as many users that you could potentially have if you can smooth these flows out. And so that's what we're going to take a look at today, is the Smart Lock set of APIs provide ways that can assist the user to make it easy to create an account, to sign up, or to be able to sign back in automatically. Now, we launched Google Smart Lock on Android last year, and some of the new things we'll talk about this year are the ability to automatically sign in the web in Chrome, new APIs that we offer to assist in signing up, and most importantly, I think what we really want to look at is some of the great implementations that partner apps, developers, many of whom are in the audience, have done, and some of the great performance that they've seen. So let's do a quick recap of the main pieces of functionality that the Smart Lock API provides. So imagine you're at I/O and you're standing in line to pick up the ticket when you get here, and you pull the ticketing app that you use out of your pocket. Last year we showed Eventbrite, and here's Ticketmaster, and we have new apps like SeatGeek coming soon. You open up the app, and instead of having to remember your username and password, the app simply shows you this blue bar and your tickets right away. There's no fumbling, having to recover your account while everyone's waiting in line behind you. Probably reduces the stress a lot when you're in a tight situation. So that's really nice to be able to sign people in automatically. And it would be even better if we could do it on the web. So let's walk through an example here with HRS. This is a hotel reservation app that Google actually uses for our own reservations. So I'm happy to see this available on the web. If you start in the native app here, you can create an account, do some searches, basically set up your entire itinerary, and then once you've created an account, you're offered to save that password or save the account that you've used if you've logged in with Facebook or with Google. And then the idea is that once you visit the website, and maybe this is where you want to complete your transaction, where you're entering credit card information, for example, you can visit the site, and instead of having to find that login button and remember to be logged in, you'll simply be automatically signed in. And this is live on the web right now, so you can even try this on HRS, and we also have Alibaba's Express app, LinkedIn, and a number of others who are live right now, like The Guardian, with this functionality on the web. So that's new this year. And just to take a look at how this would be implemented in an app that you're building, it's pretty straightforward. And that's one of the nice things, that you can do this purely with a client-side change in your app or on the front end of your website. So when you need to get somebody signed in, perhaps when your app is starting, is what our recommendation is, you construct a credential request. So a credential request has a few properties. You basically specify what types of credentials you can support on this platform, so whether it's the username, passwords, or whether you'd like a pointer that says, hey, this person has signed in with Google or with Facebook, and it's that provider you need to talk to get a token to authenticate this user. So once you've constructed the request, you pass it into our request API, and then you'll get called back. You'll get called back with any results that are available, or you can just proceed to a normal sign-in if there's nothing. So if you get something back, you can look at what you've got. It'll have the identifier, so the username or the email address, or maybe even a phone number that you've saved previously or the user has opted in to save in Chrome. And then it comes with it an account type. So if it's a Facebook sign-in, you can look at that and say, I need to talk to Facebook. Or if it's the password, you can just take that password, submit it on behalf of the user as though they typed it in themselves, set up a session, and at that point you have an authenticated user. You can show them the relevant signed-in content right away as soon as they open the app. And that's really valuable, because if we look at some examples here, one on the web that I think is worth calling out in a second is The Guardian, where calling this request API in Chrome, they can do the same thing, have someone who's a web user automatically signed in. And it's very valuable for them that they now have this huge bump in cross-device signed-in usage. And you can imagine for apps like The Guardian or the New York Times, who we showed last year, how valuable this is to be have signed-in users across your platforms as a publisher, to be able to do cross-device analytics, to keep users signed in, show them relevant content, maintain their subscription information without having to provide the support around getting signed back in or recovering from forgotten accounts. So that's the automatic sign-in functionality, but to get there, we should take a closer look at how this information is saved. And I'll show an example here in a second that I really want to call out, and that's saving non-password information. But first, looking at an app like Skyscanner, the traditional flow is you enter the password, you get this save dialog. In fact, over the last year, we've seen across all the apps that implement this a 65% save rate. About 2 in 3 users will opt in to save this information, and those users can then be automatically signed in. So to take a look at it, what it looks like now without a password, if you're clicking, for example, the Facebook button here, agreeing to the consent, and then getting a token from Facebook, New York Times will offer, and you can try this in the live app right now, offer to save the account. And what it's doing here is instead of saving a username and a password, you're saving username and a string that says with Facebook. So you know what to look for next time. When they come back, you'll see that the app will open. This is on a brand new install, completely different device. The blue bar shows they go to Facebook, get the token, sign you in, and you never even had to see the login screen. So let's take a look at how that's implemented. So in this case, you'll create a credential object that you need to save. And you can see the 2 variations here. On the top, you create a username and password account. Or if it's a non-password account, you can set other types of usernames. So for example, an email address or a phone number, and then set the type. So whether it was with Facebook, with Google, or some sort of other type that you support, like phone numbers. Then you pass the credential object into the save API. You'll get called back with a result, and the result is either successful if we can update an existing credential, or we can automatically save a non-password credential to, for example, a Google account for Google sign-in, or if you need to show a dialog to have the user interact and opt in to save. And on the web, it's very similar. You construct the credential object, pass it in as a federated or password credential. And if you'd like more information on this, you might have seen the talk from the Chrome team yesterday about how to save all types of information, how to handle the responses that come back, submit forms, or handle federated credentials to make automatic sign-in on the web possible. So taking a look at some of the really impressive performance numbers that we've seen in the last year, we have Netflix, one of our big launch partners from last year, whose growth has been really impressive over the last year, expanding to new markets. They have a lot more people using their app. But at the same time, by being able to automatically sign people in, they've in fact seen less inquiries for support around account recovery or forgotten passwords. So it's really impressive to see their growth going in one direction, but their support costs going in the other as people opt in to save this information and can be signed in automatically. This can be a huge money savings if you have a sizable support system right now and it's a subscription or pay-based service where people will definitely contact you if they can't get in. So the last big piece that I want to talk about here is how to make sign up easier. And this is a new API that we've added in the last year, the ability to get, as we call, a hint, to show a dialog that looks like this, with previously used email addresses, with accounts that are on the device. And by showing this dialog first, there's some really interesting user interactions that are possible. I'm showing an example here from the Zillow app, and you can try this out yourself. They show the email picker dialog first, which allows the app to intelligently steer the user to sign in, to sign up, or to even remind the user that they need to use Facebook or Google to log in because they don't have a password. They've even gone as far as offering to create an account without a password, one-tap account creation, which we'll look at more closely. And so for an example here, let's play the video, and we'll see the assisted sign-up experience. So on the left, we have Alibaba's Express app, user registering with email. Now the dialog is being shown through the Smart Lock API that allows the user to one-tap, fill the name, the email address, and then just have to create a password. And that's purely a client-side addition, that without having to do complex UI rework or big backend changes, they were able to assist the user to fill 3/4 of the information. And as you can imagine, they just have more people successfully completing the sign-up flow with just that little client-side change. And so in fact, we can even move forward, while the other person hasn't even finished yet, and see what the implementation work that's involved here is. And it's pretty simple. So I think this is perhaps one of the highest ROI investments that you could make in your app. One of the best learnings you could take out of I/O is by adding a few lines of code, assisting sign up, you can see much better completion of the account registration flows. And so to make it happen, you construct a hint request, as we say. You specify what type of identifiers you'd like to see. You pass that into the API, and you'll get an intent back. So that's the dialog that you can show to the user. So when the user initiates that sign up flow or sign in flow, potentially if you've merged the two together, then you have the opportunity to show them, have them pick an entry, and you'll get called back on activity result with the information they selected. It's the name, it's the email address, and it's even more importantly, something like an ID token, a verified email address that you can use to skip things like email verification. Okay, and so looking at some of the numbers here, LinkedIn ran this as an experiment on the millions of users they have, seeing up to 15% more successful signups with just the client-side work. And we've even had reports from other apps like Komoot, who might be in the audience, seeing in A/B tests as much as 20% higher conversion on sign-up. So to find out more about all the partners we've mentioned, check out this link. And the last shout out I want to give is to one of my favorite apps, WeGo, which is a travel app from Singapore, who's taken a lot of this advice to heart. They've taken account registration out of a little menu in the corner and put it into one of their primary flows with one-tap account creation, seeing over 10-fold increase in user registrations. So we hope to see what you can do in your apps too, and maybe you'll be up here next year. And with that, I'd like to hand things off to Alfonso, who will tell you about not just improving an existing sign-in system, but building a brand new one with Firebase Auth.
Thank you, Steven. My name is Alfonso, and I'm the product manager in Firebase Authentication. Not long ago, though, I was an application developer, as I'm sure many of you are today in the audience. And I remember spending sleepless nights fighting with the authentication system of my applications. Some of the problems that John, Steven, and Sebastian mentioned today, I kind of relate to. But the biggest struggles I had with authentication were much more fundamental. I never really knew if I was properly securing my users' information. I remember spending lots of time integrating with third-party signing SDKs or auth protocols and all this stuff. And I never got to manage my user sessions in an effective way. The truth is that authentication is hard, and it's something that at least I didn't care that much about. When you're building your own authentication system, you'll be going through some steps that look more or less like the ones that pictured below. You will begin by setting up your authentication backend, and you'll end up authorizing your users into your own backend resources. When setting up your authentication backend, you want to ensure, first, that it's secure, because if not, your users' data may get compromised. And second, it has to be up all the time. If not, your application will probably go down with it. Handling users' credentials is tricky. As mentioned before, you have to integrate with auth flows or signing SDKs. If you handle passwords, there's a lot of trickiness involved in that. And finally, you also have to handle the cases where your users forget their credentials. Then managing user sessions. If you want to do this effectively, you want to ensure your sessions are long-lived, so users don't have to sign in every few days they come back to your application. But at the same time, if your user's device is stolen, you want to ensure that their session is revoked. And finally, when you've implemented all of that, you have to implement all the authorization logic to take the authentication information of the user and do something useful with it in your backend. In general, all of these steps are pretty involved. And I'm pretty sure in most of the cases, this is not the core business of your application. You want to focus on other things, such as making your application awesome for your users. Firebase authentication aims to make all of these problems easy for you. In the next few minutes, I'm going to show you how you can get very easily your users signed in into your application with just a few lines of code and no deep understanding of how authentication works. In this year's I/O, as you may have seen before, we released a new version of Firebase authentication with a revamped set of APIs, some exciting new functionality, and built on top of Google infrastructure. And let's see what Firebase authentication offers. And some of you may have seen this picture before. This is one of our colorful data centers at Google. Firebase services are cloud services that run in infrastructure like the one picture in the picture here. Google takes care of making sure that the services are always reliable and available for your application. And the only thing you need to do is implement against their client or server side, as the case, to user services. With Firebase, you can get your users signed in using a wide range of options, from Google Sign-In that we mentioned before, to Facebook login, or your own email and password accounts. And doing so is very easy. This is a snippet of code of our web, using our web SDK in JavaScript, where we either create or signing a user using email and password credentials. This first line of code here does all of the following. Let's see if I get it right. It gets the email and password of the user and sends it through a secure channel up to our backend. There, it performs integrity checks on the email. It ensures that the password is strong enough. Then it makes sure that there's no pre-existing user. It hashes and salts the password. It creates a new user record in our user database. It mints a pair of cryptographically signed tokens. It sends those tokens through a secure channel back to the device, and finally persists those tokens into a client application. And with that, you've got the user signed in. But the important thing here is that you can forget of everything that I just mentioned, because all of that is done by Firebase. And the only thing you need to learn is these 2 lines of code. That's much more simple. And now let's say you want to support third-party identity providers, such as Facebook. The first thing you need to do, you need to go to a Firebase console, which is very easy to use, and enable them. And once you've got that, you're ready to write some code. In this snippet, we're using our iOS SDK with Swift, and we're taking a Facebook access token and signing a user for our application. The second line of code here in the bottom is doing something very similar as what I mentioned before. It's taking the Facebook access token, sending it through a secure channel to our backend. It's making sure that the token hasn't been tampered with, it hasn't expired. It makes sure that the audience is correct, so someone is not trying to hack you. It checks and prevents account duplication. It creates a user account in our database. It mints and cryptographically sends a pair of tokens with your user session information, persists those tokens in your client device, and finally, your user is signed in. Once again, the only thing you need to learn are these 2 lines of code. Very simple. OK, so let's say you've got some users signed in. The next thing you want to do is you want to make sure that this is actually working. For that reason, we've especially designed this console of users that you can access through this Firebase console, which is especially designed for those initial steps when you're starting to build your authentication system and want to see your accounts as they're being created. Here, you can also create and delete test accounts, and also perform some other basic admin functionalities. Let's pause a second and take a look at some of the information that you can see here. If you look at the right, you see the user UID. In Firebase, every time one of our users signs in for the first time to our application, we create a unique user ID that identifies them across your whole application. Also, take a look at the second column, which is called providers. In that column, you will see with which sign-in mechanism the user has signed in. And new on this year's version of Firebase, now your users can have more than one sign-in mechanism attached to the same account. This is very useful if, for example, you want to support allowing your users to sign in one day with Twitter and later on add email and password credentials to the same account, so they can later access their account with any of those mechanisms. OK, So we got our user signed in. Now we have to do something useful with them. The snippet of code here is from our Android SDK in Java, where we're detecting when the user signs in and personalizing the experience for them. The way that you do this in Firebase is you set up a listener on changes on the authentication state of the application. And once the event is triggered, you react to the change in the sign-in state to update your application. In this case, for example, we could personalize the user interface of our application by using the display name that comes from the signed-in user. So this is useful. With this, you can personalize the UI and make the application feel better for your user. But the most compelling use case of authentication is actually authorizing into your own backend resources or services. Doing that is also very easy with Firebase. This diagram more or less explains the steps that you need to take if you want to do this. First, your user signs in into your application. Then, you extract the token with one line of code in the client, which represents the user session. And it's signed, so you can trust it. Then you send that token up to your server, and you use one of our server SDKs to validate the integrity of the token. And with this, you can really tell that the user that is calling your application is who they claim to be. And once you've got that up in your server, then you have to apply your own authorization logic to give access to your own resources. So this is very easy, and much simpler than if you had to implement it on your own. But still, it does require a little bit of plumbing, and you have to implement your own authorization logic in your backend. So we can actually make this even simpler. As you know, Firebase services work better together. If you use Firebase authentication with Firebase storage or Firebase database for storing your users' data, all the plumbing, sending up the token to the backend, and then performing all the authorization logic is actually done automatically for you. The only thing you need to do, you need to write declarative rules which specify this user can access this resource. And no single line of code, neither in the clients nor in the backend, to make this happen. Again, massively simplified compared to if you had to implement this on your own. So let's do a quick recap. Firebase authentication is a managed authentication backend in which we offer 6 different sign-in methods. We have client SDKs for Android, iOS, and web. And we also have a C++ wrapper for games developers out there. We also have server SDKs that aid with token verification and token minting for Node.js and Java, and many more languages are coming soon. And we have a console for easy setup and user management. And there's many, many more functionalities that I couldn't cover today, but you can check out in our website, in our samples, and YouTube videos. So we took Firebase authentication, and we actually went there and spoke with different startups that they were either building their authentication system for the first time, or they weren't happy with theirs and they wanted to replace it. And here are some of the things they built and some of the things they told us. Malang Studio built today, almost in 2 days. It took them 2 weeks to build this beautiful application that you should check out. And the authentication, for authentication, they used Firebase authentication with Facebook and Google. And it took them literally an afternoon to build it. And it was production ready after then. Quaver, a beautiful music collaboration app, also used Firebase authentication. And they really liked the fact that you can link multiple accounts to the same, multiple credentials to the same account. Check out their application for the clear use case. It's really good. Then also WeMesh, Fabulous, and Revi, all existing applications, implemented for the first time or modified their existing authentication system. And they all called out how easy it was using Firebase. In general, with Firebase authentication, we've tried to make signing experience as easy as possible for you, so you can forget of all the details of how authentication works and just focus on the experience for your users. With that, I'm going to leave it to John to do a quick recap and maybe show us a little bit.
Thanks, Alfonso. Am I live? Great. So this is fantastic. Firebase authentication provides an end-to-end hosted authentication backend for you, and we've seen that it's very easy to build a full auth stack on top of that. So we're pretty much done, right? Well, unfortunately, we still need to actually do a bunch of additional work. In particular, this talk is called Best Practices for a reason. We've talked about a number of different tools and techniques to help users get signed in really efficiently, securely, and quickly. So let's all put that together into an app, which can't be too difficult, right? Right, so let's start out, and for the purposes of discussion, let's say people understand username and password flows, so we create one of these things in our actual app. We wire it up to Firebase authentication, no big deal. That's not quite complete because we, of course, need to be able to create a sign-up flow. So we pull out the username piece of that so that we can determine the difference between an existing account and a new account. From that, we either fork to the account creation flow or to the sign-in flow. And now we're thinking to ourselves, we're getting closer to shippability, but not really, because we know from personal experience and from anecdotes from our users, we're going to forget passwords from time to time. Fortunately, Firebase authentication implements a recovery flow for passwords. But we still need to implement the UI that triggers that and communicates expectations to the user. But as we talked at the beginning of the discussion, to up-level security in general and to increase simplicity and usability for our users, we want to implement Google sign-in. And maybe because users are familiar with Facebook sign-in or other identity providers, we toss that in there as well. Now, there's quite a bit of client logic that's getting involved in the mix here. And we've just introduced yet another problem, which is that I might have signed in to this particular application using my Google account, yet my Facebook account has the same email address associated with it. And that's really confusing. We do not want to actually create a duplicate account in this case. So we need to implement account linking logic, where we detect that we've got a matching identifier, and we want to either direct the user toward the mechanism that they used to sign in before, or and possibly to actually link a new provider to that same account. Fortunately, the backend provides this for us. But as we can see, there's quite a bit of client logic. Now we're done. We're not quite done. Stephen mentioned earlier today, there's a number of things that Smart Lock for Passwords can help do to help get your users in the door. Automatically signing them in, easing the sign-up process, and so on. So we add a little bit of additional logic to that. And by the time we're done, we've got quite a lot of code. But fortunately, okay, this is a one-time cost. It's out the door. We're completely finished, right? Well, once again, not quite. In the modern age, we need to do it 2 more times at least. Web and iOS, as well as Android, are all equally important. So let's toss in a web implementation and an iOS implementation. Simple, right? No big deal. So we happen to know that it's quite complex because we put all this together ourselves. And we had to keep it updated in good working order over time as well. The lines of code we found that it took to implement these entire flows for web, iOS, and Android number in the thousands, up to 16,000 lines of code to manage and maintain all the logic that we just mentioned, so long as you support all the functionality that we just supported, or that we just described, which is not always required, but definitely something that we recommend. So what's the better solution? I'm happy to announce today that we have Firebase UI authentication, which is a full stack of UI elements that implement the entire flows that we just mentioned for you on web, iOS, and Android in only a handful of lines of code to implement the flows exactly as described in the chart. So let's take a look at what some of this actually looks like. On Android, as well as all the other environments, the pattern is very much the same. Create an auth UI object, configure it with the providers and other configuration information that you want, and then display the UI. Wire up your results such that when you get the result, you get a user object or an error code. Here on Android, you can see that we're doing that for email, Facebook, and Google. And an on-activity result will get a success status indicating the user is signed in, from which we can obtain a user object if we want to, or just transition to a signed-in state. iOS is very much the same. Create an auth UI object, set your providers, maybe your terms of service URL. Then from that, generate an auth view controller. You can use that as your root view controller, or you can show that on top of your existing view controller. You wire up a delegate method such that you get the results. And web, no surprise, is very much the same as well. Configure the providers that you want, and then configure your callbacks for sign-in success as well as error. Show the UI, and you'll get called back upon completion of the flow. But that's not quite all, because we know that even though it's a couple of lines of code to implement everything I just showed to you, we want to make sure that the Firebase UI auth is customizable as well. Now, basic theming is one of the things that we support, as you can see right here, which is great to just get you out of the door in a line or 2 of code. But on a platform-by-platform basis, we support a number of different types of customization as well. In particular, on Android, you can override strings.xml files or layout.xml files to arbitrarily update all the strings or layout details in your application. On iOS, we offer a subclassing model for the home screen such that you can arbitrarily customize that as well. And on web, all rendering occurs within a container of your specifications such that the surrounding context can show whatever branding, colors, and so on that you like. This is still early days, and we're working on additional customization mechanisms as well. But on top of all of this, I'm happy to report today as well that this entire implementation on iOS and Android is open sourced, and we're going to be open sourcing the web implementation soon as well. You can inspect all the code that you like, as well as downloading it, integrating it into your application, customizing it all that you like, and please do submit bug reports, feature requests, and so on. We also have a web repository at the same URLs suffixed with -web for reports and bug fixes, and we do plan on open sourcing the implementation there too. So to recap, Firebase UI auth provides all the UI flows for all the conditions that I just mentioned, straight out of the box in just a few lines of code, implementing a number of the best practices that we've learned over the course of years at Google, and we continue to plan to support in a further fashion as well, as more identity technologies come out the door and more innovations keep getting added. We offer simple customization as well as arbitrary customization by open source, and you can inspect the code all that you like. So let's recap all of what we just talked about today. If you're an existing developer, Google Sign-In is a great way to securely up-level your user security by allowing them to use their Google account to get into your app or a website. Smart Lock for Passwords helps them remember how they got in the door to begin with, whether it's their existing password or using a federated identity provider. It also helps grease the wheels on your sign-up flow in really potent ways and helps reduce your support costs. And finally, Firebase Authentication is a full hosted authentication solution paired with UI that helps get you from zero to app in record time in just a few lines of code. Here's a couple of links to get you started. You can learn about everything that we just mentioned and more in this talk by clicking through and taking a look.